That's information with. All right. Okay. So we're going to start. Uh, like I said, my name is, okay, I haven't introduced myself, but thank you for the introduction. My name is Chinenye Ifebirinachi, and I'm pursuing a PhD in uh, applied science and technology, but my concentration is in data science and analytics. And basically, I'm focusing a lot on health data, basically using machine learning, artificial intelligence, and other data analytics techniques to kind of research and improve, you know, the health sector. So a lot of work is done like to target the minority groups in the United States. We've had projects cognitive differs from veterans and just to get it. Look at the science and artificial intelligence. Um, is what is science? Uh, this is about is a amount of data that is structured from around those. And the big question is, how can we as humans leverage how can we as humans leverage technology? So data science is basically the process of assembling data from multiple sources, structured, unstructured data. You clean the data set, you pre-process it, you investigate, because the ultimate thing you want to achieve is that you want to be able to take data and analyze it and make sense of it such that you have insights that can lead you to take actions, right? You want to be able to inform your decision making using the insights that you derive from your analysis. Because what is data, what is data if it doesn't make sense? Or what is data science if you cannot make sense of the data that you're working with? So basically, that's what data science is. You want to see the compelling patterns, you want to kind of see the trends, what information can this data set give you. And of course we have the you taking it a notch, taking it up a notch to like kind of predict possible outcomes based on the historical information that you have. So like I mentioned earlier, the general aim is that you want to derive knowledge and insights, and not just to derive, but you also want it to lead you to actions, because that is the ultimate place you want to get to take actions, right? So this Venn diagram, or this image here, basically kind of just shows how different fields intersect with each other. So data science, we can see, is an intersection of one, 2, and 3, right? So the first thing is, before you can talk about data science, subject matter expertise is the first thing you need to be aware of. So subject matter expertise is like domain expertise. What this basically means is that wherever you are, looking at getting the data from. So if you're looking at a finance data, you kind of want to have a general foundational knowledge about finance industry. You don't just want to look at finance data and you don't even know what revenue or loss, profit, income. Like, I'm just giving an example. Or let's say you're looking at the data set from a credit card company. You need to have some general ideas about, okay, what does it mean, or how do companies approve or decline credit card requests? What are the factors, what are the variables they look at, and how do these kind of fuse into what their decision making is likely going to be. So you need to have a general idea of the domain or the discipline that you are looking at, the data that the data you're looking at actually belongs to. So if it's a health data, you want to have idea of the health industry. That's what subject matter expertise is, and this is like the foundation of data science. This is where it starts. So once you have subject matter expertise, the next thing is math and statistics, right? This cannot be overemphasized, and I know that sometimes it may seem like, okay, why am I know a couple of people maybe in secondary school that are like, why do we have to do this? Why are we finding y? Why are we always looking for x? Like talking about basic mathematical equations. Some of these things are things that translate into how you're going to define real life scenarios, because you're going to be running simulations. You need to basically kind of understand statistical concepts for you to be able to analyze your data. The way you're going to analyze a data set that your outcome is numeric is not going to be the same way you analyze a data set that your outcome is categorical. So mathematics and statistics is what gives you an idea of, what kind of equation to use, what kind of modeling to use for your data set. What are you looking at? If you, after prediction, what is the assessment metric you're using to measure the accuracy of your prediction or the error rate? Some of these things are things that come from your understanding of mathematics and statistics. So it cannot be overemphasized that just having domain knowledge is not enough. You need to have math and statistics background if you're going to work in data science. The last thing is computer science using big data. So this is basically just talking about programming, coding, so it's talking about the actual technical analysis, because when you understand the domain of the data set you're working with, you have good mathematical and statistical understanding of the equations and what you need to do. Then now is for you to now implement those equations. Now is for you to actually analyze the data, and to do that you need technical expertise, which is the programming. We have a couple of languages that you can work with as a data scientist. So these are the three major foundations or three major areas of data science. These three areas are what now intersect to give you data science as a discipline or as a field, right? And it's actually, there are a lot of areas that kind of intersect with each other when we talk about computer science using big data. So the traditional research, machine learning, we'll see, how this kind of plays out in the next slide. Okay, now talking about data science and AI, right? So artificial intelligence, AI. Now this image here basically just shows us how data science is like an umbrella, and all these other techniques are extensions or contained in this umbrella. That's basically what this image shows us. So when you talk about data processing, okay, when you have a data set, what is the first thing you want to do? As long as you have domain knowledge, the first thing you want to do is to process this data set. You want to know, okay, what is my dimension? How many rows, how many columns do I have? How many variables do I have? What is my outcome? What is my target variable? What questions am I trying to answer with this data set? So once you've established that, the next thing you want to look at is basically to process your data, check for missing values, find out a way to handle the missing values, then look at your exploratory data analysis to kind of investigate the relationship between your variables, and then you have your hypothesis already when you were trying to formulate your research or your scientific question that you want to answer with your data set, right? Then here you now have to do the processing, data management, advanced visualization, user experience, data protection, deep analytics, statistics, machine learning, artificial intelligence. All these are they are like related fields of data science. They're like extensions of what or contained in what data science should be about. So you cannot talk about artificial intelligence without, mentioning the fact that it is actually an extension. It is you not just looking at how you can make sense of historical data, but you're taking it a notch, or you're taking it up a notch to actually see how can I, use machines to simulate human behavior. So basically, to conclude, that means that these are all related fields, and of course machine learning as a field is a subfield of artificial intelligence. So basically that's what this image is about. And to in a nutshell, or just talking about artificial intelligence, is basically you trying to simulate human behaviors using machines. You want machines to be able to look at a pattern and predict what is likely to happen based on a pattern. That's what you want. The same way we have neurons in our brains, you want to kind of have in artificial intelligence, especially like in neural network, you have neurons that actually also kind of perform some of these activities based on information that you feed the machine. Because now as humans we have our memories that kind of remind us of maybe past events, and then that would inform the decision we'll make eventually, right? But for when you're talking about artificial intelligence, you are the one feeding this information to the machines, and the machine is, making future decisions based on this information that you're feeding it, and kind of, giving an idea of what can likely happen or how can this likely go. So there are many different applications of AI, and we'll see that in the next slide. But this definition by Barr and Feigenbaum in 1981, I feel like it kind of defines it. But if you notice here, I striked out computer science to say data science, because it's not incorrect to say computer science, but we know that by 1981, data science was not a term that was, used as frequently as it's used today. But we definitely know that it is a part of, the field that is concerned with designing intelligent computer systems. So you want systems that can exhibit characteristics that you associate with intelligence in human behavior. You want to understand language, learning, reasoning, how to solve problems, and so on. Like, you want to take it, basically it's like you're trying to eliminate human error as much as possible, and getting the machines to actually do a better work. Not that, okay, so not that machines, well, I mean, because we are prone to human errors, right? So that's why when we kind of develop these systems, it helps improve the accuracy of what, we would likely get, compared to maybe a human being going through, like, doing the entire process. Because as humans, we are prone to fatigue, we have other life issues, we have things that could distract us. But machines don't have these things, so they are programmed to achieve this, and that's what they're going to achieve. Machines don't break down, they don't have fatigue, they don't get tired. So don't break down. Yes, that's quote and unquote. Like, you can have a downtime, but they don't break down like we humans do. They don't fault you, basically. All right, so let's look at some applications of AI, right? General applications. So we talk about machine learning, right? We know self-driving cars like Tesla, where you don't want to have like a human maybe sitting in the driver's seat, but you basically want the car to be driven by a computer system, right? Based on the information that you have programmed into it. So it can recognize traffic signs, it can recognize when there is a human being, that's a motion detection, or sensor, like it can know when there is a human being and it needs to stop, things like that. So cars are programmed to actually achieve this level of accuracy without human interference. And we have image and speech recognition. So like when you have the a rescue team, like when there's a fire outbreak, if there's a rescue team, they actually have computer systems that are powered by AI to kind of help them detect images. Because if you're going into a building where there is fire outbreak to save people, to rescue people, you don't want to randomly search for them. You want to have something that kind of helps you identify, okay, this is an image. Is this image moving? This is likely a human. So that kind of improves the process of rescuing. Like, you're not just randomly guessing, but you are making informed decisions based on what's, what has been fed into the system to say this is what a human being looks like, or this is how you can identify a human being, basically. So you have neural network. This is a major area or a major application of AI. So like in fraud detection, we know that a lot of credit card companies, a lot of banks use this a lot to detect the likelihood of fraud occurring. So for instance, when you want to do transactions with your credit card or your debit card, sometimes you will get notification from your bank trying to confirm that you are the one actually doing this transaction. So these are ways in which AI is actually helping us to improve processes in different industries, right? Sales prediction, stock exchange prediction. In robotics, of course, NASA actually leverages this a lot, and we also have, like, in the automobile manufacturing industry, robotics. We have robotics basically trying to replace the labor, human labor. Things that a human being would ordinarily do. That can, of course, like I said, we are limited in our capacity as humans. Like, we can get exhausted, but robots, machines, they can't get exhausted because this is what they are programmed to do, and that's what they're going to do. So expert systems, we all use this in our day-to-day activities. Like when you're trying to search on Google, sometimes you have suggestions of spellings of words, and Google, like if you make a mistake in your spelling, Google would suggest, oh, did you mean this? And it will actually show you results for the correct spelling. So this is how AI is kind of helping industries or organizations improve user experience. Because the ultimate reason why you're trying to apply some of these techniques or these models, or do some of these things, is that you want to generally improve the lives of people. You want to use technology to improve the lives of people. So that's the ultimate goal. And the next one is the fuzzy logic. This is like an extension of booleans, right? So we know booleans is like a yes or a no, true or false. So when it's 0.0 is false, completely false, and if it's 1.0 is completely true. So this is like when you're trying to see, okay, logical statements, analyze a logical statement. But fuzzy logic kind of takes it a notch, it takes it up a notch by basically looking at in between values, not just 0.0 or 1.0. So there could be partially true, partially false, when you're looking at standard logic. That's what fuzzy logic is about. And it can be used in speed and traffic control, business decision making support system. The next one is NLP, which is natural language processing. I know that we have come across this a lot. So when you talk about your Siri on your Apple, when you talk about Cortana on your system, Google Assistant, some of these things are ways in which NLP is helping us improve user experience. So basically, when you see a bunch of text, okay, let's take for instance on Twitter, right? People tweet on a day-to-day basis, but that information may not be useful to you because when you're looking at one information at a time or one tweet at a time, you can analyze. But what if you want to look at a bunch of tweets from a particular demography or a particular region? Let's say for instance, a country wants to know how has the general public, or what's the general public's perception of COVID-19, and how are they practicing, some of these safety guides, protocols. How are they observing some of these protocols? Are they welcoming? Like, do they welcome them? Do they actually implement them? Or how does it play out in their day-to-day life, right? So in this case, the country can actually look at, maybe on Reddit, it could be on Reddit, it could be on Twitter, it could be anywhere, but just look at the communication on those platforms, right? Kind of pull this information and use sentiment analysis to analyze to see what is the sentiment of people. Are they welcoming of this, or do they disapprove of this? So this is what NLP can actually help us achieve. Of course, in addition to spam detection in your email, speech recognition, like I mentioned earlier. So these are some of the applications of artificial intelligence. Of course, there are still some others that are not mentioned here, but it's important for us to see how this kind of plays out in our day-to-day life, and why it is extremely important that we leverage this for healthcare delivery. All right, so moving forward, let's look at a general concept of healthcare delivery and what it's about. So this is basically talking about how you deliver or provide healthcare services to customers and patients, and even how these activities are coordinated, because you don't just want to be randomly doing things. You want to be sure that you're doing it in a way that you are efficient, you're effective, and you're productive. So healthcare delivery is how you deliver healthcare services to customers and patients, and how the methods that you use in kind of bringing this solution is coordinated. That's what it is in a nutshell. Of course, there are still there could be other formal definitions, but this is what I think it is in a nutshell. So in the past 2 decades, healthcare delivery systems have been characterized by three major trends, right? Trends rather. So you have increase in diversification of structural types and products. What this means is that on a day-to-day basis, product structures, things, there is diversification of things. You have a lot of connection, like a lot of disciplines are connected, like the way it was like the way what we had available to us 20-30 years ago is not what we have available to us today. The way we use the smartphone today is not how we used it 20-30 years ago. So definitely, as the world evolves, we see that there is diversification of products and things that we can actually use to deliver healthcare, right? So change in traditional ownership, management configuration. Of course, change is constant, like things keeps evolving. How you configure your processes, how you even we know a lot about decentralization, and how blockchain is trying to help us remove all the middlemen, kind of decentralize everything and make everything like interoperable, like let everything come together, of course, while ensuring security, right? So this is basically what it's about. Like a lot of things are moving from just being here, I own this, and we have a lot of cloud services right now. Like people don't want to just have servers, physical servers. They also want to like you want to kind of change the way your mindset or your idea of what ownership should be, basically, and development of new inter-organizational patterns of care delivery and complex multi-tiered governance structures, right? So here you know that it's not just one organization now that is necessary. Like you have the insurance companies, you have the clinicians, the physicians, you have the researchers, and of course now you have a lot of technology in the healthcare industry. So healthcare delivery systems actually are evolving when it comes to the fact that a lot of organizations or a lot of groups kind of have to come together and intersect to find ways to unify and provide these services to people. And of course, governance structures can change, governments can change, policies can change. That is why we need to ensure that there is a common denominator, something that even as every other thing is changing, we need to ensure that there is a common denominator, something that kind of unites everything and ensures that no matter how much we transition, we're still, we're constantly improving the processes while ensuring that there's effectiveness and efficiency in healthcare delivery. So this information here basically about the United States, and how much of its GDP it allocates to healthcare, is an information from WHO. But the most important thing I wanted to pick from this is the fact that there is a dramatic shift away from indemnity insurance to managed care plans. So indemnity insurance is just like, an insurance company saying, if there is a damage or there is a loss, I'm going to compensate the policyholder, right? That's what indemnity insurance is. However, the managed care plans is going beyond that to say, my focus is on providing or creating a healthcare delivery system that takes into consideration cost, utilization, and quality. The quality of healthcare I'm providing, what is it going to cost, making it as accessible as possible, and also how can this be utilized. That's what managed care plans is saying. So moving forward, we basically see that a sustainable healthcare delivery system has these three major, of course there could be other underlying factors, inside these three major factors, but I would say that a sustainable healthcare delivery system focuses on utilization, cost, and quality. Quality entails a whole lot of things: the user experience, the quality of healthcare that you're delivering, how the patients interact with it, how you make how the clinicians, the researchers, everybody that needs to be in this ecosystem, how they are all getting sufficient and relevant data that can help them make informed decisions that would, of course, improve the lives of people. That's what we want to achieve. That's where we want to get to. And technology, like I said, is a common denominator, or is a factor that can ensure that there is constant improvement in these three areas, or in these three major variables that you need to look at if you're talking about a sustainable healthcare delivery system. So this is like basically segments that could be, or in a healthcare delivery ecosystem, right? Of course, it's not white or black, but I think this is very interesting when I came across this information. And basically this is where your data and your insight resides. The data set that you need to analyze, the data set that you need to look at to make improvements, to make progress, the data set that you need for the need to be able to create insight and of course take action is in these segments: healthcare providers, healthcare consultancies, insurance companies, product and software developers, then public health agencies. We'll look at it in detail in the next slide. So how do we use analytical models in each of these segments? Or actually, when you talk about, okay, this is where your data and your insight resides, how does that actually translate to practical information? So for the healthcare providers, processing of electronic health records of patients, right? And I don't know how much, I don't think, of course, in the United States things are more like organized. There is, like, you have the information of your patients, and kind of like everybody can get access to that because it's all in the system. But I believe that having that on a day-to-day basis, we are processing more data than we used to process. Like, on a daily basis, the number of data sets that we're generating, it keeps increasing. So being able to process the electronic health record of patients is actually a very important way in which you can use analytical models, in which healthcare providers can use analytical models. In effective staffing, you want to be able to predict, okay, at what time of the day do we usually have like an influx of maybe patients in the emergency room or in the ICU, to kind of determine how you position your staff, the number of people you want to have at every should I say in each location at every point in time. So this is what data can also help you do, because you have this information, and if analyzed properly, you can make sure that you're not just randomly making decisions, but you're actually making informed decisions. Enhancing prediction and diagnosis, this is like the ultimate one, because we want to improve. It's a life or death scenario, right? So when you diagnose wrongly, it means that you're going to prescribe wrongly, and what it means is that, of course, the patient's likelihood of survival kind of depreciates if that is the case, right? So you want to create patient-centric care models, democratization of health data. This is like a really important aspect, right? Excuse me. So this is like a really important aspect. Like, you want to be able to so the front line the frontline health workers, people that are in the front line, and people who are in the back end, like the administrative office, the researchers, the maybe the finance team, everybody that needs to know information about these patients gets the information at in on a real time basis. It doesn't they don't have to you shouldn't have a delay in how information is transferred about a patient. You want it to be as real time and as seamless, and as like, if it can happen at the same time, creating a system where this information gets to everyone at the same time on a real time basis would actually improve the way healthcare is delivered to a patient, right? So next, we look at healthcare consultancies, getting new drugs and vaccines to the market faster. We see how fast it was to kind of come up with the COVID vaccines, and how how fast it was for all the organizations, all the bodies that were responsible for the approval kind of came together to look at the data, see what efficiency is, see what safety is, see what the effectiveness of this vaccine is, and kind of rule out the vaccine. That's what you want. You want to be able to have to respond to situations as they occur. You don't want to slag, you don't want to, like, have delays, because the lives of people are at stake, especially when we're talking about healthcare. So you want to lower prescription drug prices, reduce the cost of managing chronic conditions. For the insurance companies, you want to basically improve population level health outcomes, because while you're aiming to make the experience as personal as possible, because each individual have different each individual have unique or unique health cases or health scenarios. Like, it differs from individual to individual, but you also want to develop models that can help you improve the population level health outcome. Of course, it could be segmented, maybe based on ethnicity, based on age group. Like, you can actually segment it based on different demographics, right? But what you ultimately want to do is to ensure that you are eliminating health disparity as much as possible. And of course, this is kind of between insurance companies and public health agencies. But for the insurance companies, you want to create accessibility. You don't want to make it such that it's only a particular group of people that can access healthcare, that can access health insurance. Basically, you want it to kind of you want to create policies that can address maybe different segments of people based on their uniqueness, or what is unique to them as a people, as individuals, right? Reduce readmission. So the likelihood of a patient getting readmitted to a facility, you want to reduce it as much as possible by making sure that all the necessary information that is needed for the first admission to actually be a progress is available to the healthcare providers. So for the public health agencies, we see how technology is helping us improve the output of food globally in agriculture, how we are, getting food out to the public, making sure that the quality, quantity, and also in a timely manner. We have emerging technologies that are helping us produce food in a larger scale, and ensuring that it gets to the consumers in a timely manner. So identifying socioeconomic health risk factors. This is extremely important, because you cannot deliver healthcare if you don't know the risk factor that is associated with it, right? And socioeconomic factors, it could be talking about maybe employment level, income level, education level. Some of these things are very, very important in knowing how to deliver healthcare to people, right? You want to reduce waste in healthcare spending, innovate payment plans. For product and software developers, this is where you have, the technicalities actually coming into play, right? So you want to link behavior and outcome. You want to be able to help clinicians make evidence-based decisions. Data is like the new oil. I'm sure we've heard about that a couple of times, because you're not just randomly assuming, okay, this is what is likely to be. No, you want evidence-based decisions that are informed by your data set. You want to develop, so this genome-based precision medicine, this is this has a lot to do with genetics, like DNA sequencing and things like that. It's a very it's an area which is like very, very hot right now, because a lot of research is going into that area. Okay, so now that we understand what healthcare delivery is and how, technology, or the different things that we can achieve using technology, or we can improve using technology, we want to see the key skills that you know you need to be able to apply data science and AI to healthcare delivery. So, I there are two major segments, or two major areas: the hard skills and the soft skills, right? So the hard skills is more like you're looking at the technical skills that you need for analysis, but the soft skills is talking about the communication skills, whether you want to communicate your results from your analysis, or even just to even interpret the problem and see what problem you're trying to solve with your data set, basically. So this is from a document by Carnegie Mellon University, and I feel like it was really informative, right? So for the hard skills, you want to look at programming: R, Python, SAS, SPSS. I forgot to add Excel. Of course, Tableau for data visualizations. You need to develop your programming skill. You need to have this skill set to be able to apply AI, data science, to healthcare delivery. Of course, having good knowledge of existing and emerging statistical and mathematical concepts, like I mentioned earlier. Database management using SQL, SQL. You want to be able to query your data set. You want to be able to, pull data from anywhere. You want to be able to manage your tables. That's basically what database management is about. Software proficiency. There are a lot of medical softwares that keep coming up on a day-to-day basis, and you need to be able to adapt and learn, not just in developing the softwares, but also in the usage and in how it can be helpful in healthcare delivery. So of course, the hard skills are very, very important, but the soft skills are even more important, because soft skills, basically, I mean, you can have a wonderful analysis, you can have wonderful results from the analysis, but if you can't communicate it properly to the stakeholders, if you can create actions from the insights that your data set has given you, then it's as good as having done any work at all, right? So the soft skills is strategic thinking and problem solving. So you need to be a good problem solver. You need to be a critical thinker. You need to be very curious, intellectual curiosity. When you see an information, you want to know, what is the origin of this information? What is this information trying to tell me? How can this information be improved? Intellectual curiosity. Storytelling with data cannot be overemphasized. You need to be able to tell good stories with your data set. You need to be able to explain it to a layman in such a way that it makes sense to them, because that is how you can get things done, right? Because some of the technical terms, I mean, if you're communicating with your boss, your management, they might not know the technical terms, they might not know the analysis you did, but basically what they want is, they want a visual representation of your results, and they want you to be able to communicate in such a way that it makes sense, to the everyday man, right? So project and change management, negotiation, leadership, and collaboration. So these are some of the skills. And when you're also talking about teamwork, like, you need to be able to have these soft skills if you're saying you want to apply AI, data science, to healthcare delivery. It is very, very important for leveraging technology to improve healthcare. So, lastly, I wanted to look at this real life use case. It's called iPad T6. It's an application on iPad, and I found it very interesting. So I think it's something that you would also find fascinating, right? So the iPad T6 is an application that was created. It's a trauma care app, and it was actually created, the creation was inspired by the experience of veterans. So veterans are like the military people in the United States, right? So basically, what this wants to achieve is that when military people or veterans are out in the battlefield, right? It could take a while, like, and maybe a person is injured. It could take a while to get the person to an actual healthcare facility. So the time between when you administer like first aid to when you eventually get them to an actual healthcare facility, you want to be able to improve their likelihood of survival as much as possible. And this is what this real-time trauma care app is trying to achieve. This is very useful. I believe it can be useful in, for accident victims, right? For accident victims, it's not just for military people, for accident victims, and especially in Nigeria where we have an alarming rate of accidents that, there are a lot of people that have lost their lives in accidents that I believe that if we had better healthcare system, it could have been avoided. If we had good first aid administered to them, if we could have managed the injury, the brain injury or whatever type of injury that occurred before getting them to an actual healthcare facility, we can improve the likelihood of survival of people. That's one of the things that this application is trying to achieve. It was created in 2014 by a group of clinicians, business leaders, data scientists, and engineers. And basically, it wants to enable medical teams to be able to impute and analyze patient data during the most critical first stages of treatment. So, to be able to again improve or increase their likelihood of survival. I mentioned earlier that this could be applied, like it has, I believe that, it's an application that can be used in in a vast in different areas. Accident victims, I am very particular on accident victims because I myself have been involved in an accident in Nigeria, and honestly, I think that it's the grace of God that made me alive today, because banking on just the healthcare delivery system or healthcare system, I know a couple of people who lost their lives in that accident that probably would have survived if things were done differently. So this T6 app aims to improve outcomes for patients and economics of care for health system, transforming clinical data into actionable insights for emergency and trauma teams' most complex patients. Now, so these snapshots are from the app's website, and basically what I just wanted to show us from here is some of the functionalities of the iPad T6. So if we know about decision trees, random forest, right? This is basically there are some conditions of uncertainties, but you want to still be able to make informed decisions. So that means that you're creating rules that will help you form these decisions. So basically, if we look at this is just it's a unique case of a patient, and it's basically saying this is the action that should be taken based on whether or not is a green or a red, right? So these are the actions that could be taken. This is just kind of imitating, or not imitating. This is basically what it means to make informed decisions under conditions of uncertainty. So you're using some rules to say, okay, if this is the case, then this is what you should do. If this is the case, then this is what you should do, of course. So I believe this is a very useful information, or a very useful model that everybody can benefit from. So looking at this, the iPad C6 also creates process maps for each encounter that the patient has, especially in the initial, in the first care delivery that they actually encounter. This is like basically, so here we see all the teams that this particular patient, who is a male, we see all the teams that have been involved in his case, and the duration of time that they were involved. Just in these singular snapshots, you also see the intervention assessments, and it is represented with numbers to see, okay, the severity of the intervention, or how the severity of the assessments, whether or not so these numbers will tell you the severity. Basically, you also look at the fluids, and you see the color green, red, yellow to kind of show the level of the fluids that were probably administered to these patients. You see the vitals represented in a graphical form, a line graph. Just in these singular snapshots, you get information that is enough for you to know what is the next thing I'm going to do for this patient, or where does this patient go from here. So this is amazing, and it's something that I believe that can be useful for a lot of people. Now, going further, we see predictive coding, which kind of improves the tedious work. Now, usually it's possible that if this was not in place, like let's give for instance, we know that when you go to the hospital, sometimes in Nigeria, sometimes your files will have to move from one desk to another before, like it has to move from office to office to office. Now, I mean, when you go to some big hospitals, like they would actually have, like on their computers, like they can actually send the information to different teams, right? But you still have to go from one office to another to get that information. So maybe you go to your consultant, he will do, analyze you, give your prescription, then he will send the information to the pharmacy. You still have to walk to the pharmacy to go there, get that information. Pharmacy will now send it to administration will send to billing. Like But this can be eliminated using this a process that communicates this information to every stakeholder. Everybody that needs information about this patient gets it at the same time. You don't have to go from one person to another to another to another. So this is actually, because when a patient is in a critical condition, time is vital. You want to save as much time as possible, and you don't want to give insufficient information. You also don't want to, as a clinician, as a physician, you don't want to have limited information. You don't want to be making you don't want to be making prescription or clinical decisions based on limited information. You need to have all the information that is necessary, and it's fascinating that every singular stakeholder is getting this information at the same time. So I think I will be wrapping up soon. I don't want to go over my time. Okay. So the next functionality of this iPad T6 is it is designed for speed, interoperability, and security, right? So again, like I said, this is basically how the ecosystem is. You have the native iOS application, which is the iPad that is built on, and this information transmits through the RESTful API platform to the EHR, integration engine, database on the cloud, IT monitoring and management tools, admin portal. The information transmits to all these different departments, and it goes there on a real-time basis at the same time. Everybody gets information updates at the same time, improving the likelihood of a patient surviving. And traumatic brain injury and every other form of trauma injury is something that is, should I say, it has very high tendency of occurring when there is an accident, whether it's on the battlefield, whether it's an automobile accident or whatever it is. But it's something that is, it's a case that can that you can easily encounter on a day-to-day basis. So, and this information here is basically where this app is deployed. It's deployed in the cloud, on-premise, hybrid edge, IT ops, and DevOps. So, anyways, all right. So, other functionalities of the iPad T6: it has accurate reimbursement for every activity. It delivers value-based healthcare agendas, because of course if the information is real time, if it's data driven, then the healthcare that is being delivered would definitely be value based. Knowledge of everything that happened and when it happened, like the information that is so for instance, if a patient is like trying to is being resuscitated, right? This process actually depletes calcium in the human body, and information has already been given. Of course, talking about AI, the system already knows, this application, it already knows that, okay, when a patient is being resuscitated, it is likely for calcium to deplete in their body, right? So what it means is that it gives signals to the person delivering the care to say, you need to actually provide this patient with calcium to compensate for what they're currently losing. This is amazing. Whatever is happening, when it's happening, the app is providing tips for how to improve and make sure that the likelihood of this patient surviving is improved as much as possible. Information meets coordination. The app provides patient location, movement tracking, full functionality without power or network connectivity, real-time data capture that matches the pace of resuscitation of patients. In conclusion, we want to basically improve healthcare delivery system, and it's important that we leverage technology to capture health data in a sufficient detail and relevance, such that you're delivering healthcare in a timely and effective manner. You don't want a situation where, so this diagram here basically shows like the different stages, or how healthcare is likely to be delivered. So this first one, which is guess, basically means that the clinician or whoever it is that is delivering the care is making random decisions. There is no methodology. There is nothing informing the decision they're making. It's more like, okay, it's likely to be. And a lot of people do, like a lot of, so, I mean, I tell, when I'm talking to like my folks, I tell them, if you're sick, go to the hospital. Like, don't guess. Okay, don't do self prescription or whatever it is. And sometimes I don't know, but it's possible to. I would say that most of the healthcare providers are probably in this stage, which is the girl stats, girl stats. So this girl stat stage is actually when a clinician is indirectly making clinical decisions based on insufficient information. And of course, what this means is that there is likelihood of generalization. They could generalize, okay, this is what this patient likely needs. But healthcare should be as personalized as possible, because every individual varies in terms of their medical history, in terms of their genetics, in terms of their socio-economic factor, in terms of their demographics, in terms of even the case, the unique health case that you're trying to address. Every individual differs. So healthcare delivery should be as personalized as possible. And personalization of healthcare delivery is what is achieved by in this stage, which is the genius stage. This genius stage is basically when you're making decisions as a healthcare provider, whether as as a clinician, as a physician, whoever you are, but you're making decisions based on data-driven decisions. You have timely information on the patient, you have real-time access to this patient's information, and you're providing the healthcare that is unique to their case on a case-by-case basis. So everything else may change, policies may change, but the healthcare industry will continue to advance in its use of analytics for adaptation and efficiency. And it's important that we move with the wave, we move with the tides, right? That we embrace and try to invest resources in these processes to kind of improve how we deliver healthcare to people. The key takeaways from this is, can you mute yourself, please? Okay, thank you. So the key takeaways from this is that as someone who is looking to apply data science, artificial intelligence in healthcare delivery, you need to be aware of the domain. Domain expertise is important. You need to know about the healthcare system. What are the regulations? Who are the stakeholders? Right? You need to be aware of the domain you're playing in. Clear definition of your problem statement. What are you trying to achieve? Business conceptualization and development. So if you know what problem you're trying to address, you can easily conceptualize the business or the solution. Basically, business here would more be like solution. So the solution, developing the solution, conceptualizing it, and translating that idea to actually become to basically materializing that idea, making it come to fruition, right? So you need to, of course, make sure that the leadership and management you're putting in charge of this solution that you're trying to create, they are accountable, they are credible, they are people who actually know what they are doing, right? Business operations, project program management, technical analysis, software development and management. So these are like areas that I believe that we should invest in if we're trying to leverage technology such as artificial intelligence, data science, to improve healthcare system in Nigeria. So these are my references for this presentation. I would like to appreciate my university professors, academic research advisors, personal professional mentors, my family and friends for their support, my friends that are here for this presentation. Thank you. Finally, thank you to the Institute of Data Science and Artificial Intelligence for the opportunity to share this information. I hope it is useful. I hope that it is something that you would, go back to maybe do further research and implement in your organization, or help other people understand, help the relevant people understand this information. So that would be all for my presentation. Thank you, and I will take any questions you may have.
Thank you, Chinenye. It's been a wonderful presentation from you. So insightful, so informative, and highly useful at this point in time. I want to thank everyone that's part of this event. And if you look at the chat, feature on your Zoom, you will see I dropped a message about Q&A session, and we'll be going into a Q&A session with Chinenye. So if you have any questions, I would advise you use the chat option to indicate your interest, so that it will be easier to coordinate who is asking a question at any point in time. Based on that, we'll have to unmute you if you indicate your interest to ask a question. Does that. I would have to go first with the questions. I would have to ask Chinenye, please, can you kind of tell us, you have a background in banking and now you're making a career in analytics geared for the healthcare sector. How did you make that kind of transition? What informed you to make such a transition to move from banking into healthcare delivery in relation to AI and analytics? Thank you.
All right. Thank you for your question. So, when I was in banking, I was a digital product manager, basically. What it means is, um, I don't know, I'm getting a feedback. I don't know whose mic I'm getting a feedback. Can you mute yourself?
Please, can everyone mute?
I think it may be your end. Can you?
Hold on.
Okay, thank you. So basically, when I worked in the bank, I worked in the digital banking section, digital products management. So basically, we kind of provided um, s- uh, payments and collection solutions to different sectors, right? So we looked at the education sector, health sector, finance, all of them. So basically the payment gateways that were on their website for collections and payments, my team was in charge of that. So my day-to-day activity required a lot of looking at the data set, because you want to increase the number of users, the number of organizations that are signed onto our payment system, our platform. We wanted to increase them, and we also want to be able to monitor their transactions, daily transactions, monthly transactions, to kind of see how to also looking at the failed. So we're not just looking at successful transactions, we're also looking at failed transactions to see how we can improve it, using the resources that were available to us. So it required a lot of analysis. It required a lot of working with data to create insights, right? And I have always wanted to do a graduate program. I'd always wanted to do a PhD. So that was when I decided, okay, you know what? I'm going to do a PhD in data science. I'm going to take this a step further to actually see how to not just to be sure that I'm using the right tools, the right resources to analyze this data set, and I have all the knowledge that is necessary for me to succeed in this field. So that's why I decided to go into data science and analytics. I have a background in mathematics. My bachelor's was in mathematics from University of Benin. So it was kind of easy. It wasn't necessarily a transition. It was easy for me to move from having a mathematics background to data science background, and to data science that I'm currently doing, rather. And so for the healthcare delivery part of it, or for the healthcare, for application of machine learning and artificial intelligence in healthcare, so my research, when I got to the United States, I was funded by a public health research center. So the public health research center was focused on aging diseases, community health, things like that. So it was focused in applying these tools to the health care industry. So, and that's how my interest in applying my knowledge or my skill set to this field actually became a thing. And it doesn't mean that that's the only field I apply my skill set to, because there are projects I've done, looking at data set from if a the automobile industry, finance industry, technology industry. So it's something that, but my major focus in terms of my dissertation is actually trying to apply in the health industry. I hope that answers your question.
It does answer my question. Thank you. We have a question from Adewale Oladiti. He's asking, is iPad's thesis an open source software? One. Two, is it restricted to military and healthcare workers? And Can't a layman make use of the software just in case of emergency when first aid treatment is needed? Can
Okay.
you take on this, please? Thank you.
Okay. So, it's not open source. To the best of my knowledge, it's not open source, and it's not just restricted to the military, but it was inspired by the experience of veterans. And the so if you look at one of the references I gave, um, if you look at these references, so if this link and this, if you go here you will find some information actually. The it's not even in the United States, it hasn't like reached a lot of, excuse me, it hasn't reached a lot of like healthcare providers. Like it's not something that is being used in a lot of facilities right now. It's still like I've forgotten this facility where it's currently, it's still like a level one use case kind of. But I think that it is something that would probably, the adoption would be, would probably improve over time. There will be user adoption, but you also want to ensure that you test out the use cases that it's actually intended to achieve. I mean, I think further information, like I said, can be found from these two links. But what I would basically say is, I personally would like to love to, or would love to see it being used, like for emergency use case, right? By a layman, by normal individuals, right? I would love to see that happen. But right now, I do not think I do not think, I'm not certain. You can look into this yourself. That is something that is currently in place. But I would say that the reason I share this information is to kind of motivate the people here who are in this field to say, okay, can we build a similar thing, a similar solution for the Nigerian healthcare system? That's the reason I share this information, because we have our unique, as a nation, as a people, we have things that probably are unique to us. So based on the resources we have, based on what we have, can we replicate the solution on a level where we can use it, or in a level where it can be implemented in the healthcare industry in Nigeria? That's the reason why I share information. But again, like I said, if you need further information on this, you can read either of these two articles. I hope you took note of the link. I can paste the link in the chat box, and you can take it from there. Thank you. I hope that answers your question, Sorry.
Adewale, I think it does. Adenike Lawa, I can see you have your hand raised. Please, if you have a question, I would unmute you uh, for like a few minutes. So please go ahead and ask your question if you want to ask her the question directly. Okay, you have 1 minute. Thank you. Adenike Lawa, are you still on?
Hello, good
Yes, hi.
Okay.
We can hear you, or you can type your
okay,
question.
okay. Can you hear me now?
Yes, I
Yes.
can hear you.
Okay. Thank you so much for this wonderful presentation. Although I missed a large part of it, I joined towards the end, but just need a clarification. You talked about sending information at the same time to all, maybe the pharmacists, the lab scientists, everybody at the same time. But I know that usually we like segregating information. The one basically that concerns the pharmacist go to the pharmacist. The ones that that the lab scientists need to know go to the lab scientists. Does it mean that with this app now, everything about the patient go to each of these units, or is
No,
it still possible to segregate the
no.
one going to each? Okay.
It's so thank you for that question. That was a good question. So and again, this is a use case I wanted to share with us, right? It's not something I personally worked on. It's something I found fascinating when I was trying to prepare this presentation. Oh well, I've actually known about the app for some time, because I had a professor that we're trying to look at it for, possibly using it for, a research, right? So it's not like the information. So if you look at this back end, is everything about the patient doesn't go to all the departments. the ones that are supposed to go to you would come to you, basically. But the difference is that it is going in real time. Everybody is getting the information they need at the same time, and it's being updated in real time. If there is a change in the in the patient's maybe body system, or if the patient's condition changes, it's being updated and everybody gets the information that they need to get. It's not like the patient's information is going to everybody. No. So does that answer your question? Hello? Hello?
I think Adenike Lawa is on mute.
Yes, it's okay. I'm okay with the answer. Thank you very much for the response.
Okay, yeah. So again, like I said, it is something you can actually. I share the links on the group chat, on the chat box, so you can look it up yourself for further information. It's I haven't personally used it. All the information I got from the application's website, right? So you can actually check out for more information, like do your own research to see the answers to some questions that you may have. But I hope that was helpful. Thank you.
Okay. Yeah. Thank you, Chinenye. From what you said, you made mention of why you made this presentation and why you actually used this uh, IPAS thesis as a use case is to instigate interest in the participants, and especially with the institute, to look at options for adopting
Yeah.
data science and AI tools to
Yeah.
improve healthcare delivery in Nigeria.
Yes.
And this is very interesting because why? The institute's focus is in harnessing stakeholders, bringing everyone together, and improving adoption and penetration of data science and AI within the Nigerian ecosystem in different sectors, so that professionals in different fields will begin to see areas of application, areas of change and improvement using AI tools and data science principles and applications and things like that. And that aligns with what your objective is with this presentation. And personally, this is a very wonderful presentation. And I'm sure that the health professionals who are on this virtual event, are really, really, really wowed by this presentation. And at the level of the institute, we have a use case already. So
Okay.
we'll be taking this up further to look at how we can design and bring design systems that can really leverage technology, specifically AI, to improve healthcare delivery in Nigeria. And we would have to take it further by getting in touch with stakeholders, bringing people together, professionals, raising expertise, domain expertise, and all that, so that we will have a well-defined structure, a well-defined problem statement, and early concepts that we can work on and develop something that will be useful for the Nigerian markets and Nigerian users. Because, like you said, healthcare delivery is really, really, really so laid back in Nigeria. It's so laid back, and technology is the missing link.
Yes.
As we speak, technology is the missing link when it comes to
Yes.
healthcare in Nigeria. And the problem is mostly people don't know, and then stakeholders are also afraid of losing control. Like you are aware, control is like opium in Nigeria. Everyone wants to be in control of different things. You
Yeah.
want to control your sector, you don't want to lose power over issues. So that's why people basically fight some of these technologies and all that. But we are happy that we are having some improvements. Many people are beginning to show interest and desire to move away from the traditional way of doing things and focusing on technology. And I'm also happy that you are already in this sector, and with your expertise already, we have you. And whenever we call upon you to make an input or be part of anything, I'm hoping you will be obliged to do that.
Okay. Well, and it's interesting that you mentioned control. Because if you look at the slide where, let me see if I can share this again. If you look at the slide where I mentioned, where I shared information about, how healthcare delivery system is characterized by three major trends, right? So change in traditional ownership and management configurations. Like there is a need for democratization of information. You need to decentralize. When you're stuck in your ways of I want to control, I don't want to lose control. Technology is not trying to take away control. It's trying to make sure that there is a that data is democratized as much as possible, because you want a situation where the information that everybody needs is getting, like, technology is what is going to help you make that information get to people faster, right? Everybody who needs it faster. And that's why it's something that we should embrace. And you talking about the missing link, this also kind of highlights that. But those are very useful. That's a very useful feedback, very useful information. And I hope that the institutes would kind of use some of the information that was shared today to improve what you already have. You said you already have a use case, which is amazing. I hope that you can use it to kind of improve what you already have. And yeah, as much as possible, as much as I can, as much as my schedule allows, I would be willing to do offer ideas or solutions as much as I can to the best of my ability. Thank you. You're muted.
Hello everyone, please, are there any more questions so that we can get done with the Q&A session and conclude? I'll give 2 minutes in case anyone has any more questions. But while we await further indication of interest to ask questions, I would want to appreciate everyone that have been part of this event. You've so far made this a success, and special thanks goes to this guest speaker, Chinenye Ifebirinachi. She's done a very wonderful presentation, and then the recording for this event will be made available. The link for you to actually have access to this presentation will be made available in the course of the next week, via email, so that you can rewatch any part of the presentation you missed. You can send the link to your friends, to your colleagues. You can have access to it anytime, any day, and still learn more. And I would make a last appeal to Chinenye. Please, can you possibly send maybe a PDF version of your presentation, or just the slide, the PPT uh, version of your presentation, so that we can also have it on our storage system in case anyone wants to go through the specific presentation without having to go through the video recording completely. Is this something you can do? And if you can, please just send it to the institute's email, and then we would make it available for every participant that would want to look at it more critically.
Okay, you can provide the email. I'll send it. That's not an issue.
Okay.
All right.
Oh, I can see there are no more questions. Would have to make it a wrap at this point. I would want to enjoin you, please don't miss the next episode. Episode 6 is going to be interesting, and we would have more guests getting involved. And also, please, the institute is trying as much as it can to expand its tentacles to different sectors of the Nigerian economy. We are focusing on the Nigerian economy basically because we believe at the level of the institute that leveraging technology will help in different sectors of the Nigerian economy. So we want to make it in such a way that different professionals from different backgrounds can get involved and see how data science and AI can help their specific sectors, and then see solutions they can be deployed and adapted to their own situation. So if you are part of this event, talk to your colleagues, speak to your superiors, let's get in touch with them. If you have people, professionals you think we need to get across to, please feel free to reach the institute on its social media platforms and on LinkedIn and by email, so that we can reach out to them and see how we can collaborate, because that's the essence of the institute. We want to collaborate with as many professionals as possible so that we can drive adoption, penetration for AI, data science, machine learning, and data driven service delivery within the Nigerian ecosystem. So thank you everyone once again for being part of this, and thank you for staying the course and being patient even with the earlier technical issues we had with the event. I hope to see you again by next month, December. Every schedule and the timing and date will be communicated later on. Thank you, and do have a wonderful weekend.
Bye, everyone.
Yeah, bye everyone. Oh, institutes is my email. I'm dropping the institute's email on the chat facial.com. Thank you. Hope you've seen this Chinenye Ifebirinachi@gmail.com. And every other person that might want to reach out via email, you can use that email for reaching the institute. Thank you. I'll be shutting down the meeting right away.